To solve a system of two linear equations, you obviously use the typical methods, elimination and substitution. But actually, if you use elimination in a general form, you will end up with a quick method to solve your system of linear equations. And this method is only used if you want to find unique solutions. And the method is using what we call the determinant. So this video is just going to prove how it comes about. So you can, if you want the general form, you can just skip to the end of the video where I explain the general form, but you'll need the beginning just to know what I mean by each letter. So if I have a general linear equation, say ax plus by cx plus dy equals to E equals to F. So notice how the coefficients go A, B, C, D, and then E and F. But A, B, C, and D can't be 0, and that's going to be clear in the end. So what I'm going to do is attempt to solve this using elimination. And I'm going to be a bit quick with the method just to show what's happening. So if I want to use this using elimination, your technique is to be able to cancel out one of the letters, so either X or Y. So I'm going to try and cancel Y now, but the two Y's have a different coefficients. So throughout this whole proof, we're going to just pretend A, B, C, and D are numbers we know. So Y have a different coefficient. This has a B coefficient, this has a D coefficient. So to solve this, I'm going to just multiply this whole thing by D and this whole thing by B. And that way my y's will have the same coefficient. So this will end up being a dx plus b dy equals to e d. And then I have c bx plus b dy equals to f b. And now I have the same coefficient, so what I'm going to do is I'm going to subtract these two from each other. So I'm going to get a dx minus b cx. These are going to be 0. And then I'm going to get DE minus BF. So now I have my letters in here. So usually when you get to this step, what you want to do is solve for x. Remember that all of the other letters are numbers we know. So in order to solve for x, I'm going to take x out as a factor. And then in order to solve it, what I'm going to do is divide by this value on both sides. So I'm going to end up with this. So overall, if you have a general equation and you have these coefficients and letters and so on, if you want to solve for x, all you have to do is take the d, multiply by e, minus b, multiply by f, and then you're gonna divide it by a multiplied by d minus b multiplied by c. So nice and easy. So if you found the x, then you need to find the y. So in order to do that, in order to find the y once you found x, you substitute it inside one of the formulas. So let's pick the first one. And let's say I have a, and then instead of x, I'm going to write this whole mess. So bf over a d minus bc. The same thing would work if you pick the other one, plus by equals to e. Now I'm going to attempt and simplify this, so I'm going to just move this whole mess to the other side. Minus, and the a belongs to the numerator here, so de minus bf divided by AD minus BC. Now what I'm going to do is, because this is E over 1, I'm going to multiply this whole thing of numerator and denominator by AD minus BC, and that way I'm going to end up with the same denominator, so I can subtract the numerators with each other. So I'm not going to go through the technicality of that, so you can just multiply by AD minus BC, AD minus BC, expand out, simplify, and so on, and you should get AFB minus EBC divided by AD minus BC. Now, this can simplify. I can take a factor of B out, so I have AF minus EC divided by AD minus BC. And then I need to get rid of this B, so I'm going to divide by B on the other side. So divide by B, AF minus EC divided by AD minus BC. And so this and this are going to cancel out, so I end up with AF minus EC divided by AD minus BC. So overall, my solutions are, well, X is going to be ED minus FB. I'm just switching the letters from what I used initially. And Y is going to be AF minus EC divided by AD minus BC. So overall, if you have a system, let's say I have 2x plus 3y equals to 9, and then x plus y equals to 25. Hopefully this will give me a new unique solution. My A in this case is 2, B is 3, C is 1, D is 1, E is 9, and F is 25. And if I want to find the solution for F, I'm just going to do what this is telling me to do. And if I want to find Y, I'm just going to do what it tells me to do. So this is a general form, but these numbers don't come randomly. They come with a purpose. And notice how the denominator is actually the same. So we also need to add the condition that the denominator can't be 0. So this denominator is special, and this is what we call the determinant of the equation. So just to talk about the general form. So in general, if you have a system of ax plus by cx plus dy equals to e equals to f, I can just take out the coefficients, and I'm going to write them out as what we call a matrix. It's fine if you haven't studied matrices. This can be done without the study of matrices. But this method is mainly used for matrices, but you can still use it here. And what we're going to do is define what we call the determinants. So our big determinant is going to be these values here. So this is our main determinant. And what the determinant does is that it's not a curved bracket, it's a straight bracket, and it takes these coefficients, so your coefficients of a and y, and they have to be in the same order. It has to be x first, and then y, and then the constants. So this is your x, your y, the constant. You can switch the x and y if you want to, but keep it consistent. And what the determinant does is that it takes a times d, and then it subtracts c times b. So it's a times d minus b times c, which, if you notice, is what we got in the denominator. AD minus BC, AD minus BC, and this is AD minus BC. So in both cases of our solutions, we're always dividing by the determinant. I do apologize if I say discriminants instead of determinants, but I do mean determinants in this whole video. And then we also find other determinants, which are first the determinant of x. Now the determinant of x, I'm not going to go through the technicality of why I'm doing this, but so there are two things you're going to do. For the determinant of x, you're going to hide the x, which means that these are the values you're going to take for the determinant of x, but we're going to have to switch them. So you're going to have to take E, F, and then B, D. So you're switching the columns, which is why it's recommended that you put x first, y, and then constant, so that you always use this method. And then the determinant of this is still the same. ED, the determinant is going to be ED minus FB. So this multiplied minus this multiplied. For dy, you do not switch. Again, I'm not going to go through the technicality of that, but what you're going to do is you're going to take the AC and the EF for the determinant of y. So we have AC and E and F. And again, A times F minus E times C. Now, where does this all come into play? Well, if you want to find the solution for x, what you're going to do is take the determinant of x divided by the determinant, and then if you want to find the solution for y, you're going to take the determinant of y divided by the determinant, and given that the determinant is not equal to 0. So this whole thing is a summary of this big mess that we did previously. So it's a summary of this. This is actually dx, and this is d, this is dy, and this is d. So if you can remember how to use this, you can. Otherwise, you can just stick to your normal method of using elimination. But where is this useful? Where it's useful if you're solving systems of equations with complex coefficients. So they become a bit tricky, and it's easier to solve when you have this method. So there's another video that goes through an example of this, and it's going to make much more sense there.